Okay, so now we're doing the review questions. A review question from 8.6 and then one from 8.7. And this question from 8.6, we did a similar one in the video for the review for the video for 8.6, the review. And theoretically, here's what's going on. Work equals force dotted with omega. The book has it, and if you go to page exercise, the example 7 on page 636, they call omega AB, the vector AB. Well, in the example on for the review for 8.6, I call it at omega, and I'll call it omega here. But behavior is all the same. And also force equals the magnitude of the given vector times its unit vector. So now, in addition to that, a similar problem similar to this is an assigned problem, number 77 on page 647. And as I mentioned, we did this a very similar problem on the video. The example on 7 on page 636, we did that in video, one similar to that in video for the review for 5.3. And it's just a two-dimensional situation, whereas now we have three-dimensional. But the theory is still, the structure of the equation is still the same. So let's deal with it. So we've got a force of 2 newtons. And so to find that force, we need 2 newtons times the unit vector. Well, the unit vector, let's see, the vector is 2I plus j plus 2k, but this isn't the unit vector, but we're going to get a unit vector shortly. And so we'll have to find first the magnitude of this particular vector, and the magnitude v equals the square root of 2 squared, which is 4, 1 squared, coefficients on the I, j, and the k. 1 squared is 1, and plus coefficient on k is 2. 2 squared is 4, so that equals the square root of 9. So square root of 9 is 3. So the magnitude is 3. If we divide each of these coefficients by 3, then we'll have the unit vector. Now we have it. So that's our force. Now we have to dot that with the vector representing the position where this thing goes to. And so it is 3, and by the way, here it is right here, 3, 4, let me write it this way, 340. And that, in terms of I, j, and k, is going to equal 3i plus 4j plus 0k. So the k doesn't show up now. And so the work equals the force dotted with omega. So this is our omega. Excuse me. Omega equals 3i plus 4j. So now work equals force times dotted with omega. So that's going to be force is 2 times 2i over 3 plus 1/3 J plus 2/3 K. Whether I put the K in the numerator or alongside makes no difference. I could have put this I in the numerator or put it alongside. Why don't I do that? To be consistent. Okay, we don't want to cause confusion. All right, now we're going to dot that with omega here. And that's 3I plus 4J plus 0K. But 0 times K is 0, so we don't have to show it. So that equals 2 times, and so we, dot product, we multiply 2/3 times 3 plus 1/3 times 4 plus 0 times 2/3. Well, 0 times 2/3 is still 0, so now here we have 2 times, and notice the 3's divide out, and we get a 2 there, plus 4 times 1/3 is 4/3, which equals, now let's get a common denominator, and will you agree, common denominator is 3, so 2/3 will be 2 will become 6/3 with that common denominator. 6 divided by 3 is 2 plus 4/3, and now equals 2 times, and when we add those up we get 10/3. So the product of 10 and 2 is 20, and that's 20 over 3, and the units are Newton meters. And we're done. There's our, by the way, that is the work.